Question 1, define a median. Well, obviously that's in the book, you can look that up. List 2 additional properties of the median, that's 1b. Okay, so that's something that you'll have to look up, but think about area, and we can think about where the 3 medians meet in a triangle, so write something down for those. So question 2a here talks about a isosceles triangle and the median. So we've got one median goes across there and that equals that, and one median goes across there when that equals that. So what you've got is triangle BNC, and we'll do that in blue. BNC is there, and the other triangle we've got is this triangle here, which is BCM. And the question says how the length of the medians 2 equal sides of an isosceles congruent triangles. Well, for triangles to be congruent, we need side angle side or side side side. So we know that in the 2 different triangles, the red triangle, that length equals that length because all sides are the same. In the 2 triangles, this side is common, and in the 2 triangles, they've got this angle here equals that angle there in the blue and the red. So it's the 2 triangles are congruent by side angle side, and the other triangle BCM is congruent. This is how they're congruent to triangle CBM. CBN. Part B talks about geometry software to determine this relationship applies for all isosceles triangles. Okay, well, you need to get the software. We haven't got that. So question 3 talks about drawing and doing the right bisectors. This is something you have to do on your own in terms of drawing a diagram and show that the point of intersection of the right bisectors of the sides of any triangle lies on the hypotenuse. So you're talking about a right triangle. Just do it properly now. So you've got a right triangle here. Aligned with the coordinate axes, which it is. So you've got the x going down and the y going down, x going across. Draw the right bisectors of the 3 sides. So basically what you're going to do is the right bisector of this side would go through here, and then the right bisector of this side would go through here. And what you're going to find is that the right bisector of all 3 sides goes through one point which lies on the hypotenuse. We can do that for yourself, try it. So question 4 here, it says verify that DEF is a right triangle. So we're going to have to find, it looks like the right angle is here. So if we're going to find the slopes of 2 sides, ED, and then you're going to find the slope of DF. And if they are negative reciprocals, those 2 slopes, then we have a right angle formed, therefore it must be a right angle. Describe another method, B. Of course, you could find the 3 lengths and use Pythagoras, and you can try that as well. So we've got a diagram here. Question 5. Gone into the green ink, sorry about that. Got it back. And question 5 talks about these 3 points. We've got point J, negative 5, 4. We'll put that there. That's J. Point K is 1, 8. We'll put that up there. K and L is negative 1, negative 2 down there. So we join those 3 points together to form a triangle. Question says the altitude of J, altitude cuts at right angles, and is that perpendicular? And it says, does it bisect line LK? Verify the altitude from vertex J bisects KL. So that's what we're trying to do now. So what we're going to do first of all is find the midpoint of JK. Of KL. Midpoint of KL. And we're going to call that point P. So we find that point there by the midpoint formula. And then we're going to find the slope of JP. Find the slope of JP. So slope of JP. And then we're also going to find the slope of LK. Slope LK. And if those two slopes are negative reciprocals, then we have a right angle that intersects the midpoint, i.e. proving the question. Question 6, list the two properties of the diagonals of each geometric shape. So we've got the square, and you're going to have to look this up in your book, the parallelogram and the kite, just list the properties there. So question 7 talks about show the line segment join the midpoints, the opposite sides of the parallelogram bisects the area of the parallelogram. Okay, so you're going to have to find the area of that parallelogram by using triangles. You can split the whole thing in two. And the bisector comes along here. And one way of doing it is to say that this is a rectangle and that this triangle here is congruent to this triangle here, and therefore we have the area of a rectangle formed. And of course, if we can prove that this triangle here is congruent, triangle 1 and congruent, triangle 2 are congruent, then we can say that the two areas, the top area is this area on top here is going to be the same as the area on the bottom here, these two areas here. So question 8, verify that the quadrilateral JKLM is a trapezoid. So all we've got to prove in the diagram is that prove that this one here, JM, is parallel to KL. So we can prove those two are parallel, then we have a trapezoid. It doesn't matter that these two are not parallel because that is what a trapezoid is, just one set of two lines are parallel. Question 9, classify the quadrilateral with the vertices T, U, V, and W. Justify the class. So you've got to go through the whole thing and we've got to prove everything really. We've got to find out all the sides, all the slopes. So T is 2, 4. There's T up there. U is 8, 2. There's U. V is 7, negative 1. There. And W is 1, 1. There. So we join these 3 points, 4 points together. What sort of shape does it look like? It's not very good, obviously. So you've got to work out all 4 lengths, all 4 slopes, and then we got to compare and contrast, look for parallel, perpendicular, etc., etc. Question 9, verify a property of the diagonals of the two UV. So there's the diagonals going across here. There's one diagonal there. Depending on what your answer to A was, will dictate what the answer to B is. If it's a parallelogram, then the diagonals will intersect. If it's a rhombus, they'll bisect each other. And if it's a square, obviously they'll be equal and they will bisect each other. Question 10, show that A and B are endpoints of a diameter of a circle. So one thing you can do for this is just substitute them in to prove that they actually lie on x squared plus y squared equals 169. And then we're going to find the midpoint. So if you know the endpoints of a diameter like this, and the diameter comes through here, the midpoint of the diameter should be the center of the circle, which we know in this case is 0, 0. So there's the point 12, 5. And the point negative 12, negative 5 is down here. If you find the midpoint after proving they're both on the circle, then you've done it. Question 12 says, divers from St. Catherine's, Hamilton, Oakville are working together to practice their deep water skills, and we have to find a practice site that's equidistant from the 3 towns. Well, we draw a triangle between the 3 towns, and all we need to do is find the perpendicular bisector of each of these 3 lines, and that will be the point that is equidistant from the three towns. So the practice site in the middle of the lake somewhere because of the perpendicular bisector. All you have to do is describe it. Perfect. Practice, chapter 3, practice says, which of the three triangles have at least two medians that are equal in length? Well, of course, A is an equilateral triangle. That's one of the hot favorites. B is isosceles. E is isosceles 2, and it's a right triangle. And D is scalene, and C is just a right triangle. So make your mind up. What do you think should be the answer for that? Question 2 says, which of the triangles in 1 has a median that is also an altitude? So you need to work through and decide which of the medians is also an altitude. Question 3, sketch an example of each of these types of quadrilateral. Show the diagonals on each sketch and indicate whether they are equal in length and whether they bisect each other. So for each of these, square, rectangle, parallelogram, rhombus, trapezoid, quadrilateral with no equal sides, draw each one out. Draw the diagonals. So for a parallelogram here, the diagonals would be this way, and then you need to go and research, look up exactly what the diagonals do to each other. So for this one here, the diagonals here, that would equal that, and that would equal that. That's the only thing you can say for a parallelogram. Question 4, show that two of the altitudes of an isosceles triangle are equal in length. So if we draw an isosceles triangle like this, two equal sides, so this side equals this side. One altitude goes that way and hits there, and one altitude goes that way and hits there. Can we prove that these two altitudes are equal in length? Well, you can by looking at congruent triangles. We know that this length here is shared by both triangles. We know that this angle here is the same in both triangles, and we also know that they have a right angle in common, and therefore it's angle, angle, side. The two triangles are congruent, and therefore we can say that this side must equal that side by corresponding parts of congruent triangles. Question 5, verify that triangle ABC is isosceles. Well, it should be easy by now. We're going to work out the length of this and the length of that by the distance formula, and that will prove it's isosceles. Verify that the centroid of triangle ABC lies at 6, -1. So it's a bit trickier. You've got to find the midpoints of the three sides of the triangle and draw the medians. And wherever the medians meet will be the centroid, and you've got to prove that that is the point 6, -1. One way of proving that the point is 6, -1 is to find the intersection of two of the medians. So find the equation of this line here, and then find the equation of that line there, and then find out where they intersect by putting the two equal to each other, and it should be the point 6, -1. Question 6, show the triangle with vertices D, E, and F is a right triangle. So same process, draw the triangle out without moving the paper around, draw the triangle out, and find out which angle you think is the right angle, and then find the slope of this, find the slope of that, and look for negative reciprocality. Verify that the midpoint, this is 6b now, verify the midpoint of the hypotenuse of DEF is there. That's the midpoint, is equidistant from all three vertices. So what you do, you work out that distance, work out that distance, and work out that distance, and then it's equidistant from all three. And that's the midpoint of the hypotenuse. 7, use analytic geometry to verify the quadrilateral JKLM here. So you're going to find out the four distances. The first thing you're going to do for a rhombus is find out the four lengths of this rhombus, and then you're going to have to find the four slopes. And you verify that that is perpendicular to that, and the other one is that that is perpendicular to that. Parallel to that. So you've got to prove the lines are parallel, not perpendicular. Question 8, find the midpoint of each side of the quadrilateral with vertices, so PQ. So you're going to draw your triangle out, your quadrilateral out, and it says find the midpoint of each side. So you're going to find the midpoint, the four midpoints by the midpoint formula. show that the joining the midpoints of the adjacent sides forms a parallelogram. So therefore you're going to join these four sides together. You just found the points of, and you've got to prove that this side equals this side, and that side is parallel to that side. Or you can do it with the other two sides here, it doesn't matter, but you only need to do it for one set of opposite sides. Question 9, verify that C.52 is the center of the circle that passes through the points T, U, V. So all you're going to do, if you've got the points, if you draw the points out, for instance, you've got one point there like that, and you've got a center, and you think that goes a circle, so you're going to find out this distance, and that distance. If the three are equal, then it is the center of the circle. Question 10, verify that ABC is not an isosceles trapezoid. So I think we're going to assume it is a trapezoid, but still we're going to have to find the slope of this line, the slope of that line, and then to prove it's not isosceles, you need to prove that that length does not equal that length. And then you've proved, because the question says, is not an isosceles trapezoid. Question 11 talks about geometry software. We haven't used that, so I won't worry about that question. We're going to question 12. Verify that PQRS is a rhombus. So again, we're going to find out all four lengths. We're going to prove they're all the same, and then we're going to find out all four slopes. We're going to prove that slope is parallel to that one, and of course that this one is parallel to that one. Part B, verify the diagonals of PQRS bisect each other. So you're going to have to find the two diagonals. And by doing that, you're going to find the midpoint first. And if you find the midpoint, you can find out all four distances, and two of them should be equal, and the other two should be equal. Verify that the diagonals of PQRS meet at right angles, so that's fairly easy. You're just going to find the slope of this line here, and find the slope of that line, and look for negative reciprocals. Question 13, a new hospital will serve the four small towns on the map. Where would you build the hospital? Justify this location. So I guess you've got a quadrilateral that if you join the four towns together, the best idea would be to put the hospital at somewhere near the intersection of the diagonals. Is that fair for everybody, or would you put it perhaps in here somewhere, which is a bit closer? Or could you draw a circle around all 4 points, and then the hospital would be in the center of the circle, equidistant from all 4 points. Question 14, the vertices EFG, find the coordinates of the point of intersection of the medians. So again, if you've got a triangle, here of EFG, the three medians will cut the baselines in half, and they'll all meet at one point, and you've got to find the coordinates of that point. So you have to find the equations of two of those lines and find them where they intersect. B, find the coordinates of the point of intersection of the right bisectors. So you're going to go through the same thing with finding right bisectors. Again, you've got to find the equation. There's a right bisector that way, the right bisector that way, and the right bisector that way. And find the intersection of two of those lines. C, find the coordinates of the point of intersection of the altitudes. Do the same thing, find the equations. And verify, D, verify the 3 points of intersection are collinear. Interesting, great question. So for A, B, and C, the 3 points should be collinear. That's a very advanced question, a lot of work involved, but try it and see how you get on.